Alright, again with these weird curves, weird functions that we don't know so much about, but we can easily sub in some points like x equals 0 and x equals 1. So I might do that first just to give me an idea of where I'm at. So if I put x equals 0 in there, I'll get obviously y equals 0. So I know that's a point on the graph. There we go. If I put 1 in, I'm going to get 1 minus 1, which is 0. So also, let's put 1 here. 1 is also, so I've got 0 and 1 are also points on there. And it's talking about sketching this graph and this y-squared graph, which of course is the same as if I square rooted both sides and took the plus and minus both. So a reflection in the x-axis. And the reason why it's got anything to do with the top is if you look under that square root, so if I look at this bit, really I've got square root x times 1 minus x, which is square root x minus x to the 1.5. I should write it as a half, not square root. There we go, which is up here. So if I do y dash of that and take the positive and negative depending on if I'm looking which part of the curve I'm looking at. So let's look at y dash to start with. So it goes a half, x to the power of minus a half, and then minus 3 on 2, x to the power of, so if I take away 1, I still have a half there. All right, so if we have a bit more of a look at that, that's like this. Minus 3 root x on 2, if I make a common denominator. So that stayed the same, and I times this by root x. So I get 1 minus 3x. Is that right? I've got a half, x to the minus a half, minus 3 on 2, x to the half. So I have 1 on 2 root x minus 3 root x on 2 is correct. Oh, that's correct. All right, so say, say I wanted 2x instead at the bottom, so there's not a square root on the bottom. So let's make that 2x. So let's just rationalize the denominator by timesing by root x on root x. What would I have? I would have root x, 1 minus 3x, and 2x on the bottom. All right, so what does that tell me about y dash? First of all, it tells me that y dash is undefined at x equals 0. Y dash is undefined. I can't have it. It's undefined at x equals 0. All right. And then if I look at the top, this would have given me x equals 0 for y dash equals 0, but I can't have it. And this bracket will give me x equals 1/3. Where if I make that equal 0, if I make y dash equal to 0, I get x equals 1/3. So I know this is going to be a stationary point where x equals 1/3. So what we can do is sub in 1/3 to the actual function. So y equals the square root of 1/3 minus the square root cubed, which it would be square root cubed, which would be that. If I put that together, 3 root 3, that would be, so times that by 3, so 3 minus 1 would be 2, and if I times that by root 3 on root 3, I get 2 root 3 on 9. 2 root 3 on 9. So this point, 1/3 2 root 3 on 9, is a stationary point because y dash equals 0 at that point. So let's say that is about here. All right, so that's going to be my 1/3 2 root 3 on 9. All right. Okay, so if I then, hopefully you kind of understood that. So that was just looking at y dash. Let's make it a bit more in here. There's my y dash, looks nice that way. So we might leave that as my y dash. All right. We don't need that. Oh, just that we are graphing both the plus and minus case. So this is just y dash of the plus case, and then I'm gonna reflect it in the x-axis. All right, so you can kind of see what it's looking like already. we might need to know what happens as, we can look either side of, for y dash of 1/3. Oops. So if I have x is 1/3, let's put a little bit to the left of 1/3, 1/6. Let's put a little bit to the right. Let's put 4/6. How about that? And then we've got 1, and then, well, let's have a look at 2, something like that, and look at y dash. All right, because we already know it was undefined at 0, so undefined at 0. Now, if you put 1/6 into y dash, so here's y dash here, what you'll find is it's positive. If you put 1/3 in, we will get 0 because that's the stationary point. If you put 4/6 in, hopefully you'll get a negative. If you put 1 in, that was just a point on the graph, not a stationary point. So when we actually put 1 in, 1 times a negative, so you get a negative. When I put 2 in, I'm also getting a negative. All right, so you can see what's happening. It's clearly increasing up to our stationary point, and then it's decreasing, and it's still continuing to decrease. All right, let's just check that. So really, as our x gets, I didn't write it. I wrote it somewhere, but I've rubbed it out. Anyway, I mean, that's all we really need to know to sketch it, because I need the plus and minus version, so I need to also put this version in. There we go. So we can tell as x goes to infinity, y will go to infinity, and we also could tell from when I had written the equation as y equals plus or minus x, 1 minus x all squared here. So we've got, as x gets bigger and bigger and bigger, this is always positive, and then this is going to be positive because we're only in the positive here. You can already see that we can only have x is greater or equal to 0 as well. So that makes sense that we've only got that side. And also we knew that as x goes towards 0 from the right hand side, you can have a look here. So we know it's undefined. So, you know, this point here is undefined, and it's the top is kind of winning, so it's going to be a positive gradient if it were a gradient, or just to the right of it. So this looks fine. This looks good for this curve.